Okay, so service mesh for legacy software. Let's talk about it. You know, legacy software, this thing that was written 5 or more years ago in your company, probably before you got there. Most of the developers already left. Some of them are still there, but every time you ask them things, they pretend they don't know anything about it. And usually it runs on this outdated EC2 or VM or maybe a bare metal machine in your on-premise data center. No one likes legacy, right? And every time you have to touch it, you kind of put your hazmat suit on so you won't get any old vulnerabilities. So if nobody likes legacy, why we wouldn't just delete it? And there's a reason. While many companies going into this awesome roadmap of great products that are running on those amazing technologies like Kubernetes and serverless and all of this, what usually pays for all this development and this roadmap is this legacy service and this legacy software. So legacy is actually awesome. So not only we can't delete it, in many cases we should actually embrace it with all its challenges and make sure it's functional. And we see those challenges of legacy software all the time, every day. So, hi, I'm Lev, I'm CTO at TerraSky, and TerraSky is a leading system integrator, and we help our customers fall in love and feel their relationship with their software and infrastructure, whether it's Kubernetes or serverless or legacy software on-premise. So let's talk about the challenges of legacy software. So first thing is compliances. Many of our customers have to be SOC 2 compliant or PCI compliant or HIPAA compliant, and a lot of times it goes into encryption in transit discussion. So now they have to somehow issue the certificates in the right format, provide all the details of the company and the department and the common name, and then they actually have to, let's say if it's Java, import it into Java key store and restart the application. And usually it's a lot of fun, and because it's so much fun, certificates are created like for 10 years, so statistically it will be a problem of the next DevOps or sysadmin guy. So it would be great if we could have a certificates automation and certificate rotation for our legacy software without touching our software, and if it could be like easy and automated, because everyone hates certificates. So this is challenge number one. Another challenge is error responses, and our legacy software and any other components it communicates with from time to time may respond not with 200s okay, right? It can sometimes respond with, I don't know, 404, sometimes 418, I'm a teapot, but sometimes like 503, I'm dead, give me a second. And in many cases, if you just wait a second and retry again, it might work. But our legacy software sometimes lack this knowledge of how to do retries properly and how to implement it. So it would be great if we could have this mechanism kind of without changing our code. The last thing I want to discuss, but there are many other things, is scale, right? When our legacy software was developed, scale was probably very different from what it is today, and infrastructure was different. So when in today's world, a lot of traffic and requests hit your service, it's very important being able not to die in the middle. But there's one additional problem. It's called cascading failure. When our service becomes slow, it can actually cause other services become slow as well, because they're communicating with it and they're kind of exhaust the resources. So what we want to have is some kind of development pattern like circuit breaker that would actually prevent it. So circuit breaker, for example, would actually notice that the service is actually not responding properly within a certain period of time, and it will just stop moving all the traffic or directing all the traffic to it until some cooldown period, and then it will resume it again if the server back functioning properly. So it would be great if we could have those kind of modern development pattern for our software. So how can we solve it? Well, the most obvious is we can solve it on application level, right? We can just take our legacy Java service and we can implement retries, we can implement timeouts, and we can implement encryption there. The only problem is that most of our developers left, and every time we touch it, it breaks, so it's probably challenging. Another issue is that I might have multiple implementation of my software in different languages, so I have to do it multiple times. Maybe we can do it some other way once. Maybe we can do it on a network level, so we can have our Java service and our Ruby service, and we'll just send a request, and then something smart like Layer 7 load balancer will actually take this traffic, and this load balancer will implement retry timeout, encryption, and maybe other functionalities, and then we got everything we wanted, or most of it. The challenge is now that this load balancer has to process all the traffic east-west, right? And it has to be super resilient, probably at least one more, and have capabilities of scale out because it's a lot of traffic. So usually it's very hard and very expensive. Wouldn't it be awesome if we could kind of go into the future, bring all the knowledge of how to handle all the problems that we have in technology and kind of solve it today? Well, this is exactly what Service Mesh will feel to your legacy software. This is how it will behave. So for those who don't know what Service Mesh is, let me explain it very briefly. Imagine we have two VMs, and on one VM we actually have our legacy software that has no idea about any changes that happen in the development in the last, 5 years. So it will send a super naive request, and this request will be captured by the proxy, and this proxy is actually smart, and it will add all the capabilities that we talk about, the retries, the encryption, the modern patterns, modern monitoring, and it will send it to another proxy on another machine. And this is another smart proxy that will actually decrypt it, make sure that this traffic is allowed, and do everything that is required, and then send it as a plain, naive request to service B, which is also a legacy service that has no idea what just happened. So those proxies are our data plane of the Service Mesh, and this is one part. The second part of Service Mesh is the control plane, because we need to configure those proxies. So this is in general what Service Mesh do. This is the layer between the application and the network that kind of have these capabilities. Now, there's another great feature of Service Mesh is that everything now is based on communication between proxies. So we no longer care about IPs. That means if we have duplicate IPs, let's say in our on-premise and cloud, or duplicate IPs in two VPCs, we can actually have this communication without any problem, because now it's a Service Mesh communication and not IP to IP communication. So you're probably saying, if Service Mesh is so awesome, why wouldn't I use it all the time? Why not everyone use it? And there's a couple of reasons. So one, it will definitely require more resources. It will require some memory. It will definitely require more CPU because it's doing encryption. So that's reason number one. It will definitely add more latency because now you have more components that you go through, more hops. Maybe your legacy software is perfect and there are no changes that are required, and maybe you implemented everything there. But if that's not the case, then probably Service Mesh is way better than the alternative when you can't develop anything, or a network solution is too expensive for you, assuming you can live with additional latency. Okay, so this is a Hashi talk, right? So we're talking about Consul Service Mesh, and Consul is a great solution for Service Mesh, and it's actually an open source project, and it exists since 2014, and it supports more than 20,000 nodes per single cluster, which is insane for Service Meshes to support that. And in a sidecar in our data plane that I've mentioned previously, it actually leverages Envoy Proxy, which is another open source solution that is highly adopted in the industry, and there are another service meshes that are actually leveraged. So I'm going to show you a demo, but I want to kind of explain the components that are there and what are we building. So I have two VMs. Both of them are running our legacy software. One of them called Marty McFly, the other one called Dr. Brown. And we will have Consul server in which we will register our services, and this will be our control plane. And we will have ingress gateway through which we will send all the traffic into our service mesh. And I will use my laptop, so I will be able to actually send traffic through this ingress gateway into the mesh. So let's run the demo. Okay, so I'm using Demo Magic, and this is just to avoid typos, but all the environment is live. So first of all, let's open our AWS and see the instances that we have. So as you can see, we have Consul server, this is our control plane. We have Consul gateway, this is our ingress gateway, and we have our two machines, Marty McFly and Dr. Brown. Okay, so let's take a look at this IP. So as you can see, Consul server is .14. So let's actually connect to Consul UI. And Consul has this nice built-in UI. So you can actually see that Consul itself is already registered here. We're looking at all the services. And we have our Dr. Brown here service. We don't see Marty McFly yet, but we also have our public ingress configured with one upstream. So if we take a look at this upstream, you can actually see that it's kind of grayed out, and it says that even though it's configured, the service is not registered yet, and we will register it as part of this demo. Now, if you take a look at the nodes, you can actually see that we have 4 nodes, and one of them has 0 services, right? This is our Marty McFly. Now, there's one more capability that I want to show you, and it's intentions. And intentions is like a firewall rules. So I can actually say, let's allow all the services communicate with Dr. Brown, and let's allow all the services communicate with Marty McFly. Okay, so let's connect to Marty McFly. This .95, it's actually the public IP of our Marty McFly. So as you can see, it's responding with I'm Marty McFly, and let's see how it behaves. I've implemented a couple of error pages. One of them is this error 500, and we will iterate 5 times, and error 500 randomly responds with internal server error. So you see, we got it here as well, and then it worked. Okay, there's another error page that I have that called delay. Delay will actually stop for 3 seconds once in a while. So let's see that behavior. So this stuck, and then it worked. Okay. All right. So now I actually want to register the service and actually configure the service mesh on this machine. So I'm connecting to the machine, connecting to Marty McFly, and I'm running Demo Magic here as well. And the first thing I want to show you is what ports are open and listening on this machine. So I have my SSH and my DNS that is actually forwarding it to Consul. And this is my application. This is 8080 Python. And then I have my Consul agent running here. So just to confirm, I'm doing a curl to localhost. And as you can see, it's still Marty McFly. This is the configuration of our service. It's pretty straightforward. I'm configuring the ID of Marty McFly, name, the port it's listening on, and I'm saying that it's going to have sidecar proxy and it's going to work in a transparent mode, meaning all the traffic will be intercepted and just pushed into specific port of our Envoy. So let's remove the suffix of demo and restart Consul agent. Okay, now I'm going to enable our envoy, our data plane, and I'm going to start it. Part of the startup script of the envoy is the command of Consul traffic redirect, which actually configures IP tables for me. So let's see what we have. It does a couple of things, like this thing. My envoy is actually going to expose Prometheus metrics now. So I'm actually getting this modern monitoring capabilities for my legacy software that has no idea what Prometheus even is. So I'm actually allowing traffic to those ports. I'm allowing traffic from Consul and envoy services. And I'm basically saying everything that will try to leave my machine, let's capture it and let's redirect it into this port. And this port will be port of envoy. So let's see that. I'm doing netstat again, and you can see this is the port that I mentioned. This is envoy, and as you can see, this is the port of the Prometheus, and it's also envoy. Good. So let's get back to our main demo. Now, because it's part of the service mesh, I can't actually access directly to this machine, so I have to go through ingress gateway. So this host is actually pointing into our gateway. As you can see, 115. Let's take a look. It's 115. Great. So if I just open it in a browser, we should see that I'm Marty McFly. First thing I want to show you is our traffic encryption, right? So what I'm doing, I'm connecting to a Marty McFly, and I'm running TCP dump on any interface, but I'm actually listening on localhost port 8080. This is how our legacy application should receive traffic. And we expect it to be not encrypted, right? Because our application has no idea what encryption is. Okay, so let's do a couple of requests. And as you can see, we actually see here requests themselves. And if we go here, we should see that it responds with I'm Marty McFly at some point. There you go. You see, this is our response. Okay, so as expected, plain text. Now let's actually see what the traffic looks like when it leaves our machine toward the ingress gateway back to the end user. So I'm again doing TCP dump, but this time on the IP of our ingress gateway on the port of envoy. Okay, so let's do a couple of requests. Okay, and now you can actually see that everything here is just gibberish and it's unreadable, so it's encrypted. Okay. The other thing that I want to show you is the configuration of the application resilience, right? The retries, the circuit breaker. So as you can see, this is Consul config.tf. So I'm actually configuring my Consul through my Terraform. So one of the things that I want to show you is this configuration. This is proxy defaults configuration, and this will be applied to all the envoy sidecars that we have. What I'm saying here is that mode will be transparent, the protocol will be HTTP, and that Prometheus will listen on this port. Basically, our envoy will expose on this port metrics for Prometheus. This is the configuration for our circuit breaker. So it actually, I have to configure both the limits and the passive checks, and this will enable the circuit breaker functionality for me. Another thing that I want to show you is our retries and timeouts. So I'm actually configuring this service, and what I'm saying is that for everything in each of the services that I have, everything on path of / and under it, I will actually do 10 retries for error codes 500, and if the request takes more than 2 seconds, I will actually cut it and I will show the timeout error. Okay, so let's connect to the UI of Consul itself, and I want to show you how things change. So now, as you can see, we have Marty McFly service here, and in my public ingress, we can actually see that now it's actually redirecting it to this service that is now registered. And if I click on the service itself, you can actually see that we're starting to get some monitoring here. And this is based on Prometheus metrics. And in our nodes, you can actually see that all the servers have now one service. Okay, so let's do our error 500, and this time we will do it 10 times to make sure that it's not just random, but actually resilient. Okay, we survived that. Now let's try to do the delays. So as you can see, we've got request timeout, and another one, and another one, and again another one, and all of them were, very luckily for us, more than 3 seconds. So what I want to show you is that this functionality of application resilience is actually not something that I have only north-south, but also east-west. Right? So now I'm actually connecting to my Marty McFly, but I'm doing a request to Dr. Brown to error 500. And as you can see, that went well. Again, error 500, we didn't get any error response. But I want to show you also access control, the intentions that I mentioned earlier. So let's go here and let's configure intention that says Marty McFly and Dr. Brown can no longer talk. And we'll save it and we'll connect back here. And we'll run exactly the same request. And this time we will get no response. Great. So let's make sure that it's not accidental. So I will actually remove this again. And we will try it again. Okay, so that went well as well. Let's take a look at our modern monitoring capabilities now. So I'm connecting to Grafana. And what I actually want to do is configure this dashboard ID, which is a dashboard for a Consul service mesh. So let's import it and let's specify the ID. And let's define this data source and do import. And as you can see, I just took a kind of default dashboard and I get metrics, and I have here my data centers, my clusters, my applications, and pretty much a lot of knowledge out of the box without configuring much. So let's get back to the presentation itself. Okay, so you saw how Service Mesh can provide us application resilience and security for our application. Now, you're probably asking yourself, well, what is a good fit for me, right? When should I use it? So definitely, if your legacy software is implementing HTTP, it will be great. You will get encryption, you will get access control, you will get application resilience, monitoring, all of those capabilities. But even if your application is some proprietary TCP, you will still be able to get encryption and access control, and maybe some basic monitoring, depends on what are you implementing, but there's still value even if it's just TCP. Now, you saw the demo of Linux, right? And a lot of legacy software is running on those Linux VM, but a lot of software, legacy software is also running on Windows machines. So Consul can actually run on Windows, and you pretty much covered there. And it definitely runs on Kubernetes as a first-class citizen. So not only your legacy covered, but also your Kubernetes covered. And if you're going into a serverless direction, or maybe you already have it, you can also have Consul as part of your serverless technologies. So basically, Consul can be your service mesh across pretty much any platform and any technology. So I want to conclude this idea that today a lot of engineers assume that Kubernetes and service mesh is the obvious couple, but also like you deploy it in a way of first implementing Kubernetes, then day 2 you implement service mesh, and then maybe day 3 you actually go for your VMs. And my point is that service mesh is valuable for any software that you have today, whether it's a legacy or not, regardless to your journey with microservices and Kubernetes. Now, I'm also sharing a couple of documentation and additional materials here, and I really suggest you check this community office hours with Blake that actually shows a great demo of how you can set up a service mesh on VMs. So thanks a lot, and as Dr. Brown said, future is what you make it, so make sure it includes service mesh. Thanks a lot.